Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing the relation among the chords of a circle. So let's have the following objectives in today's lesson. At the end of the lesson, the students should be able to letter A. Determine the relation among chords of a circle. Letter B. Find the measure of the chords of a circle. And letter C. Value accumulated knowledge as means of new understanding. So we have the relation among the chords of a circle. So the first relation is the diameter of a circle is twice its radius. So we have the formula radius is equal to 1/2 times the value of the diameter, or diameter is equal to 2 times the value of the radius. Then the second relation, we have the radii of the same circle are congruent. They have equal measure. And then number 3, the perpendicular bisector of a chord passes through the center of the circle. And then we have the Pythagorean theorem, wherein the formula in finding the missing sides of the right triangle is c squared is equal to a squared plus b squared, wherein c is the hypotenuse, a is the shorter leg, and b is the longer leg of the right triangle. So we have different variations of the formula depending on what is unknown. So if the value of the hypotenuse is unknown, we will use c is equal to square root of a squared plus b squared. If the value of the shorter leg is unknown, we will use b is equal to square root of c squared minus a squared. If the value of the longer leg is unknown, we will use a is equal to square root of c squared minus b squared. So let's have an example. In circle P, segment PS is perpendicular to segment RQ. So we have this segment which is a radius. So we have radius PS or segment PS, and it is said that it is perpendicular to the line segment RQ, this one. So we have to find the following. Number 1, if segment PS is equal to 15 cm, what is the measure of segment PR, segment PQ, and segment RT? So we will find the measure of segment PR, this one, this radius, and the measure of segment PQ, which is also a radius. Since segment PR and segment PQ is a radius, then the measure of segment PR and segment PQ is also equal to the measure of segment PS because segment PS is also a radius. And from the given statement earlier, all radii in one circle are congruent. So the measure of these two segments is equal to 15 cm. So next, let's have the measure of segment RT. So this segment. So segment RT is a diameter. So all we need to do here is to multiply the value of the radius by 2. So multiplying 15 cm times 2, the measure of segment RT is equal to 30 cm. So next, so using the same figure, let's have question number 2. If the value of segment PQ, the radius, is equal to 15 cm, the value of segment PN is equal to 7 cm, what is the measure of segment NQ? So since segment PS is perpendicular to segment RQ, and PS is a perpendicular bisector, meaning to say it divides segment RQ into two congruent parts, therefore the two triangles here is an example of right triangle. So meaning to say, to find the measure of the missing side of a right triangle, we will use Pythagorean theorem to solve for the measure of segment NQ. So we have segment NQ, so the value of the shorter leg is equal to square root of segment PQ raised to the second power, wherein PQ is the hypotenuse or the longest side of the right triangle, minus segment PN to the second power, which is the value of our longer leg. All we need to do is to substitute the value. So bring down segment NQ equals square root of the value of segment PQ is equal to 15 raised to the second power minus the value of segment PN, which is equal to 7 raised to the second power. Then we will simplify. Bring down segment NQ equals square root of 15 times 15, which is equal to 225. And then we have 7 times 7 is equal to 49. So we have 225 minus 49. Then bring down segment NQ equals square root of 225 minus 49 is equal to 176. And then we will get the square root of 176, and that is equal to 13.27. So the measure of NQ, which is the shorter leg of the right triangle, is equal to 13.27 centimeter. So next, using the same figure, let's answer question number 3. If segment NQ is equal to 12 centimeter, what is the measure of segment RQ? So since segment PS is a perpendicular bisector of chord RQ, then segment RN is congruent with segment NQ. They have the same measure. So if the value of segment NQ is equal to 12 centimeter, then the value of segment RN is also equal to 12 centimeter. So meaning to say, to get the measure of segment RQ, we will just add the measure of segment RN and the measure of segment NQ. So adding those two segments, so we have 12 centimeter plus 12 centimeter is equal to 24 centimeter. So the measure of segment RQ is equal to 24 centimeter. So let's have our next example. In circle M below, segment BD is equal to 3. Segment KM is equal to 6. And segment KP is equal to 2 square root of 7. Use the figure and the given information to find each measure. So number 1, let's find the measure of segment AM. So segment AM is a radius of circle M, and also it is a hypotenuse of triangle AMK. So to find the hypotenuse of a right triangle, we will use the Pythagorean theorem. So we need the measures of the longer leg and the shorter leg. So the measure of the longer leg, which is segment MK, is equal to 6. And the measure of the shorter leg, which is segment AK, is equal to the measure of segment KP, which is equal to 2 square root of 7. So segment AK is also equal to 2 square root of 7. So we will use the Pythagorean theorem. Segment AM, which is the hypotenuse of the right triangle, equals square root of KM to the second power, which is the longer leg, plus segment AK to the second power, which is the shorter leg. Then we will substitute the value. So bring down segment AM equals square root of the value of segment KM, which is equal to 6 to the second power, plus the value of segment AK, which is equal to 2 square root of 7 to the second power. Then we will simplify. Bring down segment AM equals square root of 6 times 6, which is equal to 36, plus quantity 2 square root of 7 to the second power is equal to 4 times 7. Bring down segment AM equals square root of 36 plus 4 times 7 is equal to 28. Then bring down segment AM equals square root of 36 plus 28 is equal to 64. And then after that, we will get the square root of 64, which is equal to 8. So the measure of the hypotenuse of the right triangle AMK is equal to 8 units. Next, let's solve for the measure of segment KL. So in this case, since we know that the measure of segment AM, which is a radius, is equal to 8, so we can find the measure of segment KL because segment LM is also a radius. So if the radius is equal to 8, so meaning to say, if we add segment MK and segment KL, it must be equal to 8. So to get the measure of segment KL, we will just subtract the value of segment LM, which is equal to the value of segment AM, minus the measure of segment MK, which is equal to 6. So subtracting that, 8 minus 6 will be equal to 2 units. So the measure of segment KL is equal to 2. And then after that, let's find the measure of segment MD. So since segment MD is also a part of a radius, which is we all know that the measure of the radius is equal to 8. So to get the measure of segment MD, we will subtract segment MB, which is equal to 8, minus the measure of segment BD, which is equal to 3. So subtracting those two numbers, 8 minus 3 will be equal to 5 units. So the measure of segment MD is equal to 5 units. So next one, let's compute for the measure of segment CD. So to solve for the measure of segment CD, we will draw a radius here. We will connect point C and point M to form a radius. So the measure of our radius is equal to 8, and we have formed here a right triangle. And again, we will use Pythagorean theorem. So segment CD equals square root of segment CM, which is the hypotenuse, raised to the second power, minus segment DM raised to the second power. All we need to do here is to substitute the corresponding values. So the value of segment CD is unknown, equals square root of the value of segment CM is equal to 8 raised to the second power, minus the value of segment DM is equal to 5 raised to the second power. Then we will simplify. Bring down segment CD equals square root of 8 to the second power equals 64, minus 5 times 5 is equal to 25. Then bring down segment CD equals square root of 64 minus 25 is equal to 39. Then we will get the square root of 39. So the value of segment CD is equal to 6.24 units. And then let's have number 5. So we will find the measure of segment DS. And we all know that these two segment CD and segment DS is congruent because segment BM is perpendicular to segment CS, and it has a perpendicular bisector which divides the two segments into two congruent parts. So whatever the measure of segment CD will be the measure of segment DS. So the measure of segment DS is equal to 6.24 units. And then next, let's have number 6. We will find the measure of segment MP. So segment MP is a radius, so therefore the measure of segment MP is equal to 8 units. The next, let's have the measure of segment AK. So the measure of segment AK is also equal to the measure of segment KP. So the measure of segment KP is equal to 2 square root of 7. So the measure of AK is equal to 2 square root of 7 units. And then for number 8, what is the measure of segment AP? So to get the measure of segment AP, we will just add the measure of segment AK plus the measure of segment KP. So we have 2 square root of 7 plus 2 square root of 7 is equal to 4 square root of 7. So the measure of segment AP is equal to 4 square root of 7 units.